Welcome back to another interesting lesson in physics. In this lesson, we shall understand simple machines. What is a simple machine? Well, a simple machine is a device used to make work easy. There are basically 6 types of simple machines. That is lever, pulley, gear, inclined planes, wheel and axle, and a screw. Let's begin with a pulley. A pulley is a simple machine having a grooved circular disc over which a rope passes. The load is connected to one end, while the effort is applied on the other end. It helps us to multiply force and change the direction of force. A pulley is applicable in wells when you want to get water out of the well. Number 2, the lever. The lever is a rigid bar resting on a pivot, also called the fulcrum, used to move a heavy or firmly fixed load within one end when pressure is applied on the other end. Number 3, the gear. This is a toothed wheel that works with others to alter the relation between the speed of a driving mechanism, such as the engine of a vehicle, and the speed of the driven parts, that is, the wheels. Number 4, the wheel and axle. This is simply a simple machine consisting of a wheel that is attached to a small axle so that these two parts rotate together, in which a force is transferred from one end to another. Number 5, inclined plane. An inclined plane is another simple machine consisting of a sloping surface used for raising heavy bodies, such as planes and vehicles. The force required to move an object up an incline is less than the weight being raised, discounting the friction. The steeper the slope or incline, the more nearly the required force approaches the actual weight. Lastly on our list, the screw. This is a short, slender, sharp-pointed metal pin with a raised helical thread running round it and a slotted head, used to join things together by being rotated, and passes through the wood and other materials, and is held tightly in place. Let's now move on to what mechanical advantage and velocity ratio mean. Well, mechanical advantage is a measure of the ratio of the output force to the ratio of the input force in a system. It is used to analyze the forces in simple machines like levers and pulleys. Despite changing the force that are applied to the conservation of energy is still true, and output energy is equal to the input energy, and it carries no units. It is calculated as mechanical advantage is equal to load over effort. Let's also understand velocity ratio. This is defined as the distance moved by the effort over the distance moved by the load. Now, for us to calculate efficiency, we'll use mechanical advantage and velocity ratio. So efficiency is equal to mechanical advantage over the velocity ratio. One thing to keep in mind that efficiency cannot be 100%. This is so because some of it is lost to heat. And that is all for this lesson.